Hey everybody, it's Zeb. I just wanted to do a quick couple of videos to work through some of the calculus, some of the derivative examples that were on the practice problem that I gave you from class. So my intention is to make two videos. This video will cover the first 15 problems, and the second video will cover the problems 16 through 30. If the videos get too long, I may make more videos just to keep the file sizes down, but I think two should work. So we will just jump right into it here. The first derivative, or the first problem that we're given, says that f of x, all right, is equal to x squared minus 2. Now, anytime that you are given something like this that has a constant term in it, that is something that doesn't change with your independent variable, you just ignore that when you take the derivative. So the number 2 is never changing, right? It's always the number 2. It's not going to change as x changes. So we can just ignore that from taking the derivative. And so we get that our derivative, f prime of x, is equal to, using the power rule, 2x to the 2 minus 1, which is, of course, equal to 2x to the 1, which is just 2x. So the derivative of x squared minus 2 is simply 2x. The second problem says that f of x equals x minus x cubed. Well, of course, x minus x cubed is the same as x to the 1 minus x cubed. Using the power rule, we can see that f prime of x, that is the derivative with respect to x, is then just 1 times x to the 1 minus 1 minus, okay, the video is jumping around here, hopefully it stops, 3x to the 3 minus 1. So this is, of course, just x to the 0 minus 3x squared. X to the 0 is just 1 minus 3x squared. So that's the derivative for problem 2. Moving on. Problem 3. For problem 3, we have that f of x equals x squared plus 3x minus 6. So here we have another one of those constant terms that doesn't change as x changes. So for that reason, we can get rid of this 6. It doesn't change anything, right? Because it's just a constant. And so we can take the derivative here using the power rule. So we get f prime of x is equal to 2x to the 2 minus 1 plus 3x to the 1 minus 1. So this leaves us with 2x to the 1 plus 3x to the 0. Well, 2x to the 1 is simply 2x, and 3 times x to the 0, anything raised to the 0 power is 1, so this is going to be simply 2x plus 3. So this is our derivative for x squared plus 3x. So let's see. Ooh, I can move that. That is so cool. All right, moving on. Number 4, we have that f of x is equal to 2x squared minus 4. Again, we have a constant term. All right, our constant term is the 4. That does not change as x changes. So we can ignore it. All right, so we take the derivative, f prime of x is simply going to, we're applying the power rule now to 2x squared. So f prime of x is going to be this 2 times 2, All right, so 2 times 2x to the 2 minus 1, which is, of course, 4x to the 1, which is just 4x. So the derivative then of 2x squared minus 4 is simply 4x. We'll move this over here. Problem number 5. Here we have that f of x equals 2 over x. So this is clearly the most difficult one that we've done, but it's not especially difficult. When you can remember the rules of fractions and exponents, you won't have any trouble with this, because you will realize that this can be rewritten as 2 times 1 over x. So 2 times 1 over x is the same as 2 over x. And of course, this is also equal to, 2 times x to the minus 1. So this is the same thing. So we can then apply the power rule to 2x to the minus 1. So when we do so, we get f prime of x is equal to, so we get negative 1 times 2 times x to the minus 1 minus 1. There should be an equal sign here. So that then is equal to negative 2 times x to the negative 2. So this is the derivative now for problem 5. So I'm just going to have to move all of this stuff up out of the way. All right. Moving on. Number 6. So number 6 builds on what we just did in problem 5. So 6 says that f of x is equal to 4 over x squared. 4 over x squared minus x squared over 4. So these are really inverses of each other. Now it's important that we recognize that we can rewrite this. So we can rewrite this as 4 times x to the minus 2, because it's 4 times 1 over x squared, which is the same as 4 times x to the minus 2. So that's this component, right? This component is this term. Now we need to rewrite this fraction. So we get minus, now this is just 1/4 times x squared. 1/4 x squared. So we can take the derivative of this using the power rule. Doing so, we get f prime of x is equal to, so now we take our negative 2 and multiply it by that 4, and we get x to the minus 2 minus 1. So that's this term, right? Now we've got the second term. We need to take the derivative of this second term. So we get minus 2 times 1/4 x 2 to the minus 1. So now it's just simplifying. So this is going to be negative 8x to the minus 3 minus, now 2 times 1/4, that is 1/2. So minus 1/2 times x to the 1, which is of course just minus 1/2 x. So I can rewrite that. So minus 8x to the minus 3 minus 1/2 x is our derivative for problem number 6. Now, of course, I'm showing more steps here than are really necessary. You don't have to show all of these steps. Once you get the power rule down, you can kind of skip some of these steps, but for now it's good to see them. So problem 7. we have f of x equals 2x to the 10 minus 4x squared. Now this one's pretty easy. So we have f prime of x is equal to 2 times 10x to the 9. I'm going to go ahead and skip that, bringing the power down by 1 each time. Minus 4 times 2x to the 1. So then our derivative is equal to 20x to the 9 minus 8x. So that's the answer for problem 7. Problem 8. For problem 8, we have f of x is equal to 3 times root x, the square root of x. So again, use your knowledge of exponents to help you here. 3 times the square root of x is equal to 3 times x to the 1/2. Now that looks like something we should be able to take the derivative of. So f prime of x is going to be equal to 3 times 1/2, times x to the now 1/2 minus 1. So 3 times 1/2, this is just 3 halves, x, and now we've got 1/2 minus 1, so this is going to be to the minus 1/2. So that's our answer for problem 8. Actually, we worked through that problem today in class. So 3 halves times x to the minus 1/2. Problem number 9. This one is, it looks similar, except it's a little bit easier. So f of x is equal to x times the square root of 3. Now the square root of 3 here is a constant term, right? It's not, there's no variable, but the reason why we can't totally ignore it is because it gets multiplied by x. So as x changes, this is going to change as well, right? So this matters, but we can also treat this as being the square root of 3 times x to the 1, and that looks like something we should be able to take a derivative of. So we can take f prime of x, that's our derivative with respect to x, is going to be 1 times the square root of 3 times x to the 1 minus 1. So of course, this becomes x to the 0, which is just 1. And so we're left then with this, 1 times root 3, which 1 times root 3 is just equal to the square root of 3. So there you have it. The derivative of x times the square root of 3 is simply just the square root of 3. Now this is something worth knowing in general, that anytime you have the variable x that's multiplied by some number, the derivative is simply going to be that number. So for instance, if I'm taking the derivative of 2x, the derivative is going to be 2. If I'm taking the derivative of 5,280x, the derivative is going to be 5,280. Okay. So let's move some more stuff up here in my junk pile. There it goes. All right. Now we are on problem 10. So problem 10 has that f of x equals x to the 4 over 4 plus x minus 2. So again, that first thing that I would do here, if I were you, would be to recognize that the minus 2 can go away. It's a constant term. All right. And now we can rewrite what we have. We'll call it f of, we'll just say, so it's not exactly true, but it might as well be. that this is equal to, it's not because of the minus 2, but 1/4 times x to the 4 plus x. All right, so taking the derivative of this is exactly the same as taking the derivative of this, even though they're two different functions, because they only differ by that constant term. So therefore, the rate of change in the two is going to be the same. So the derivative then, f prime of x, is simply going to be 4 times 1/4 x to the third plus, now the derivative of x, remember anytime you have something like this, it's just that number that it gets multiplied by. Well, this is 1x, so this is going to be just a 1 here. So what is this? Well, the 4 and the 1/4 cancel out. Well, they don't cancel out, they get multiplied. 1/4 of 4 is just 1, so this becomes x cubed plus 1. So that's our derivative for number 10. So notice that when you see something like this and it's written kind of weird looking and you see some fraction, it's not necessarily that difficult to take the derivative. You can probably easily turn it into something that looks familiar to you. So for instance, problem 11. All right, problem 11 looks a little different than anything we've seen. F of x here is equal to x times x plus 1. Well, what we're going to do in this case is just multiply things out. We're going to factor that x, or distribute that x. So doing so, we get x times x. That becomes x squared. Now plus x times 1, which is just going to be x. And that's something we can easily take a derivative of. F prime of x will be 2x. Right? We've seen that before, that the derivative of x squared is 2x. And the derivative of x, remember this is 1x, is just 1. So 2x plus 1 is our answer here for problem 11. Moving on. Problem 12. Problem 12 has that f of x is equal to x squared minus e squared. Now this is a little bit tricky. Not really, but it just requires you to know what e is. Well, e is the number Euler's constant. That's what it's called. And it's a constant term. So what do we do with constant terms? We can safely ignore them. Right? It drops out. So what's the derivative? That was pretty easy. We've seen this one a bunch of times. It's just the derivative of x squared, which is 2x. So there it is. Problem 13. We have f of x equals 5x to the third minus 5 over x to the third. All right, now this term is simply 5 times 1 over x to the third, which is, of course, equal to 5 times x to the minus 3. So that's the same thing. So recognizing that and rewriting can help us out. So the derivative then, f prime of x, we're going to start by taking the derivative of this thing. Well, this is going to be 5 times 3, so that's 15x squared. Now we've got this minus sign, so we've got minus, and so now we're going to take the derivative of this term. So we've got negative 3 times 5, so that's negative 15x to the minus 3 minus 1 more now, because that's what the power rule says we've got to do. We've got to take 1 more power away. So this is equal to 15x squared, the negative and a negative, right? And when you subtract a negative, that's the same as adding, plus 15x to the minus 4. So that's our answer for problem 13. It's simply 15x squared plus 15x to the minus 4. Problem number 14 looks complicated because of the parentheses, but it's really nothing new. F of x is equal to 6x plus 5 minus 3x plus x squared. So really nothing new here, just make sure that you're mindful of that minus sign. So this is, of course, equal to, we could write this out without the parentheses, 6x plus 5 minus 3x minus x squared. And we can easily take a derivative of this. So f prime of x simply becomes 6. Right? This 5 cancels out. It's a constant term, right? It just drops out of the derivative. So we get 6 minus 3, because the derivative of 3x is 3, just like the derivative of 6x was 6, minus 2x. All right, so I'm going to shift this over here. And so this, we can simplify. We get 6 minus 3. That's just 3 minus 2x. So there is our answer for problem 14. So the last problem that I want to do in this video is problem 15. And problem 15 has that f of x equals 2x squared minus 5x plus 10. So again, the 10 is going to go away because it's a constant term. And so taking the derivative of a constant term would just be 0. So we can just ignore it from the start. So f prime of x is going to be 4x minus 5. So there you have it. Those are the 15 derivatives, problems 1 through 15 on the Power Rule Practice Worksheet. In the second video, we will come back and we will do problems 16 through 30. They're a little more complicated. So we'll see you then.